So our project is on basic indefinite integrals.
I'm Richard Deng.
And I'm Aaditya Peri. So what is an indefinite integral? Well, an integral is a function where the derivative is given, and it's used to express the area underneath the function's curve. And indefinite, according to Merriam-Webster dictionary, is not clear in amount or length. Putting the two together, we can say that an indefinite integral is a function where the derivative is given and is used to express the area underneath the function's curve, only without specified limits. Well, how do indefinite integrals work? Well, let's look at one. First we see the integral symbol, next we see a function called the integrand, and then after that we see d of x, or infinitely small change in x. The integrand is the derivative of some function, or the function whose area under the curve we're trying to find. And to get this function, we find the antiderivative of the integrand. Well, what exactly is an antiderivative? To take the derivative of a function, certain rules and methods must be followed, we know that. Now, taking an antiderivative is just undoing these rules and methods. For example, say we're given x squared, and we know that because of the power rule, we know that its derivative is just 2x. And similarly, if we're given 2x, we know that its antiderivative is just x squared. And it's important to mention that the derivative of a constant is 0, so we need to add a variable to represent the constant after every integral is taken.
Our first example here is, what is the indefinite integral of 2x squared plus 3? So, what function's derivative is 2x squared plus 3? This kind of looks like the result of the power rule of a function. Alright, working backward with the power rule, we know that there's going to be 3 parts to this antiderivative. There will be x cubed term, an x term, and a constant, which Aaditya mentioned before. Alright, also working with the power rule, we know that the product of the coefficient and exponent of each term in the integral will equal the coefficient of the corresponding or the resulting term in the integrand. Thus, the coefficient of the x cubed term will be 2/3, and the coefficient of the x term will be 3. There won't be any coefficient on the constant, which we'll represent with c. So, in the end, the integral of 2x squared plus 3 is 2/3 x cubed plus 3x plus c.
Here's our second example. Now, what is the integral of 3 over x? Well, we know that, so pretty much we're trying to find out what function's derivative is 3 over x. And we can pull the 3 to the outside of the function because it's a constant being multiplied by something else. So the integral we're taking is actually 3 times the integral of 1 over x. And we know that the derivative of ln x is 1 over x. So that makes the antiderivative and the integral of 1 over x ln x. And afterwards we have to multiply that by the 3 outside the integral, so we get 3 ln x. And once again, this is very important. There might be some constant whose derivative is 0, and we need to represent that with c. Our final answer is 3 ln x plus c.
Alright, our third example here is, what is the integral of 3 over the quantity 2 plus 2x squared? Alright, like the previous example, we can take out a constant to make the integral more easy to integrate, or take the integral of. We can pull out a 3 over 2. Alright, this makes the integral really 3 over 2 times the integral 1 over the quantity 1 plus x squared. Alright, we know that the integral of 1 over 1 plus x squared is arctan of x. When we multiply this by the 3/2 we pulled out earlier, we get 3 over 2 times the arctan of x. Alright, now all we have to do is add a constant c to get our final answer. 3/2 arctan of x plus c.
Thank you for watching our presentation. We hope that you really enjoyed the calculus just as much as we do.
Good luck in your future.